Hello once again, game developers, and welcome back to Let's Make Pong. This will be episode 5, and last time we left off, we had just finished getting our ball bouncing around the screen using our update ball method. And today, we are going to work on getting the paddles up on the screen and work on polling our input. For this game, it'll be the keyboard to get those paddles moving. Now, in between episodes, I did a little code work here just to fix some things. I noticed last time when we had our ball moving, it was stuttering across the screen a little bit, and I tracked that down to how we were getting our delta time variable. But before we were using just get delta time, which, as when we talked about it before, that uses smoothing over several frames, and switch it over to get raw delta time, which just gives us the time that's between last frame and this frame, and that seemed to give us a better result. If we run it here, the ball should be nice and smooth now, no problem. And the other thing I did is in our game object class, I did another helper method here for setting the velocity x and y components. This way, for this episode, when we start moving the paddles around, we don't have to get the velocity vector, change it, and then set it back on the paddle. We can just change the components directly. So it'll save us a little bit of time. We'll use that in a second. Alright, so the first thing we want to do, we want to get the paddles on the screen. So let's do a draw method where we draw the paddles. Just like we did draw ball, we're going to do draw paddles. I'm going to pass in DT. Now we're not using the DT variable in draw ball or draw paddles yet, but we will in the future. So I'm passing them in just for now. And then we're going to render that with a filled rectangle just like the ball. And it's just going to be paddle 1 get X, paddle 1 get Y. And then it needs the width and the height, just like the ball. And the same thing for paddle 2. Let's just copy and paste, make our life easy here. And we'll do a search and replace. We'll replace paddle 1 with paddle 2. Replace that, and there we go. So if we run this, our paddles are going to be down in the bottom left corner of the screen because we haven't moved them anywhere yet. But here they are, stacked on top of each other. Both of them are there. So let's get those set up where we want. Now in Pong, you're going to want one paddle on each side of the screen for the player to control, and you're going to want them offset from the sides of the field a little bit, just to give them some room. You don't want them butted up against the screen. So let's put a comment here just so we can have some code separation. We could drop these into separate methods, but it's a little too specific. We probably won't be resetting the ball any more in the future than this bit of code, so there's no reason to really separate those out. But we're going to move the paddle, the first paddle. That's going to be on the player one will be on the left side of the screen. So we want to move it, and remember we need to take the size and the position and of the field into consideration when we do this. So we want to move it from the left side of the screen by the position of the field, and then give it a bit of a buffer. And since in the future the size of the field may change, we'll probably wind up using like a percentage of the field width, just so as the field gets smaller, the amount of space that the paddle is offset is smaller. Because if we made it like a set pixel width, say we made it where it was 64 pixels away from the side of the field. As that field got smaller, that width would stay the same, and so it would look proportionally bigger than we wanted to. So let's do field.x, and then we're going to add on to that percentage of the total field width. Let's do like 10%, right? So 0.1 will give us 10% of that field width. And that will move it horizontally to where we want. And we also want to center it vertically in the field. taking the same things into consideration, the position of the field and its total height. So we'll offset it from the bottom of the field, and we'll center it based on the field height minus the height of the paddle, just like we centered the ball last time. And so we divide that by 2, and that'll center it vertically on the screen. So if we take a look at that, that should have paddle 1 in the position that we want. Right here. So it's centered vertically, and then it's offset from the left side about 10% of the total width of the field. So that's good. And we'll do the same thing for paddle 2, except this time we need to offset it from the right side of the field. So it'll be field.x plus field.width minus, because now we're going to offset it towards the left from the right side, 10% of the total field width, and then the y centering will be the same as paddle 1. Alright, let's check that out. Yep, there we go. There's paddle 2, there's paddle 1. Our ball's still bouncing around. It goes through the paddles right now because there's no collision with those. We'll get to that. So far, so good. So we have our paddles drawing. We have them reset to position. So let's get them moving based on player input. And to do that, we're going to do an update method where we update the paddles. Let's do 2 separate ones, since we just have the 2 paddles. We'll do an update paddle 1. We may change our minds on this in the future, say we added more paddles. This isn't the best way to do it, but for now, this will work. So now we can update our paddles independently here. Now when you're dealing with input, libgdx provides 2 main methods to do that. You can either do it by a method called polling, and all that is accessing the input class that libgdx provides every frame and doing manual test on the keys that you're interested in. So each frame we would say, has the player pressed, or is the key is like W, is key W pressed this frame? And if it is, we can use that and do something with the code. The other method is event driven, and you can access that by either extending the input adapter class here or by implementing the input processor interface yourself. The input adapter just implements the things for you, so you can only override what you're interested in. But if you use the input processor interface, you'll have to implement them all. But the difference is, for input adapter, you'll write your input adapter class, you'll fill out these methods, and then they'll only be called when, say, that key is pressed down or that key is released, and then you'll get a key code telling you which specific key was pressed. This also handles mouse events. That's what the touch down is, since it handles Android touch interface. They combine the mouse and the touch together. So you have touch down, touch up, touch dragged, when the mouse is moved, and when your scroll wheel amount changes. So that's all the input events you can pull in. Now the input adapter is a bit more complicated. It has to process the key codes and then provide feedback to the game about what happened. So it's a little bit more complicated than we want for our simple version here. So we're going to go with input polling. And to do that, we're going to set 2 booleans, because our paddles are only going to move up or down. We don't need to worry about horizontal movement. So we're going to give 2 variables here for moving down and moving up. And we're going to set those booleans based on the input we get per frame. So we will access that GDX helper class again, and we'll go down here to input. And this provides some methods here for us. We can do is button pressed, and that's testing if a mouse button is pressed. Is cursor catched? That means that the cursor can't leave the center of the screen, which is useful for like if you're making an FPS or something. You have is key pressed, which is what we're going to use, and that'll detect if a specific key has been pressed. Is touched tells us if there has been a mouse click. Is touched, you can test for specific mouse buttons, but for now we'll use is key pressed, and it wants an integer that represents the key we want to test for, and libgdx provides for us. It has the keys class, which defines all the keys for us and returns an integer value for that. So if we're doing paddle 1 on the left hand side, I say we do W for up and S for down, and then on the player 2 they'll be able to use the arrow keys up and down to control their paddle. So let's test for up first. So we'll say keys.w, and so if this frame the player has pressed the W key, they want to move their paddle up, we're going to set the value move up to true and move down to false. And then we will test for the S key as well, doing the same thing. Say keys.s. Yep. There we go. And we're going down, so we'll say move down equals true, and move up equals false. Now we could just change the velocity of the paddle right here as soon as the keys hit, but using some Boolean values to kind of capture the input before we move on to changing the velocity allows us to handle things like multiple key presses. Say within this frame that the player hits both W and S. This lets us determine which one we want to do before we actually set the velocity of the paddle. So now we'll set the velocity of the paddle based on the values we just set. So if we have move down set, if move down is true, we are going to set the velocity of paddle 1 using our new function here that we set up for this to how fast we want it to move per second, right? So we'll try 350. That'll get the paddle moved across the height of our field currently in about 2 seconds. So that feels okay. And actually needs to be negative 350 since it's moving down. Remember, y is positive on the OpenGL axis here for going up. And then we'll say else if move up. So if our move down is false and move up is true, we will do the same thing and move up by the same amount. And then else, if neither one is false, or if neither one is true, both of them are false, that means the player, this frame has not hit anything. So we actually want to stop the paddle. Otherwise the velocity will stay the same and it'll just keep on going. So we will set paddle 1, set velocity 0, 0. Alright, so let's test that out and see if that works for us. So I'm hitting W, nothing's happening, hitting S, nothing's happening, so let's take a look at Y. And it would be because we didn't actually change the position based on the velocity. We need to call our integrate method for the paddle 1 and try again. Alright, hitting W, there we go, it's moving up. So you can move off screen right now, so we'll have to take care of that. And then I hit S and it moves down. That seems like a reasonable speed. That feels good at the moment, so that's good. So we need to do some collision with the field like we did with the ball. We need to see if the top of the paddle has gone beyond the top of the field, and if so, set it back and then set its velocity to 0 so it stops moving. And then the same thing for the bottom of the paddle. If it's gone beyond the bottom of the field, stop it. So let's do that. Let's do if paddle1 dot top is greater than field top. Paddle1 dot move, and we're not going to move it horizontally just like the ball. We're going to move see, paddle1 dot height. Remember, we have to offset it since we're testing the top of the paddle, but we actually need to position it by the bottom, so we need to make sure we take the height of the paddle into consideration here. And then we want to set the velocity to 0 so that it stops moving per frame. And then we will do it for the bottom as well. Paddle1 dot bottom is less than field bottom. Paddle1 dot move. And since we're positioning it by the bottom of the rectangle and we're testing against the bottom, we don't have to offset it here. And then also set the velocity to 0. And they're still integrating, so let's test this again. See if that works how we expect it to. Nope, not at all. So what else did we do wrong? Let's think here. Just like with the ball, we need to update the bounds as well. So now the actual bounding box that determines the physical position of the paddle will follow it along. And one more time, we should be there. Oh, that's another error. Here we mistakenly set the X position of the paddle to the side of the screen, which is not what we want. We need to actually do that based on the current position of the paddle. Alright. Every time you code, you're going to hit bugs. So you just got to think about them, figure out where we're at. And there we go. It's the bottom. That's a little jerky. Like you can see it, I'm holding down the key. It wants to stop and go down and stop and go down. And the reason is that's happening is because it's how we have the paddle integration happening. We have it happening at the end of the frame. So we do all the collision correction first, and then we integrate it. So if it winds up below the field, that's how it's going to be drawn, because the updating's done, and then the draw method comes in, draws the paddle how it was when we stopped updating. And so we need to move this. So basically we're going to integrate for what the current velocity is. Move that here after we set the velocity. And then after we move it, we check for collision and put it back in place if need be. So let's test that one more time. There we go. Holding it down. No stuttering. Up, same thing. So now we can move the paddle up and down within the boundaries of our field nice and smoothly. So that works. And we're going to do the same thing for paddle 2, except we're going to use different keys. So we're going to use the same code. We'll just do a copy and paste job here. Now it's a little bit of code reuse. We could do this better, and we probably will refactor this in the future. But for now, for just getting our simple game up and going, this would be okay. And instead of using W and S, we're going to use the up and down keys, the arrow keys, which are defined by up and down in our keys class. And then we want to change all these paddle 1s to paddle 2. So we'll just select them and do a copy and or a find and replace. So instead of paddle 1, we want paddle 2. Alright, let's test that. So now I'm using the up key, I'm using the down key. That moves our paddle 2. Paddle 1 moves. Both of them will move at the same time just fine, so we'll be able to play 2-player at our computer here. So that'll be great. And I think we'll go ahead and stop here. Next episode, we will work on getting the ball colliding with the paddles so that we can actually start playing the game. And as always, the code will be uploaded to the repository. The link will be in the description. You can follow me on Twitter. And if you like this series, leave me a comment in the comment section. Give me a like. It'll help other people find us. And thanks for joining me.